Well, thanks so much. I'm really thrilled to be here. It's a total, it's a complete honor to be invited to come speak here at PyCon India. This is very fantastic, and it's really cool to see all of you out here. We're working on getting the projector running, but I'm just going to go ahead and start. My slides don't have a ton of stuff on them other than pretty pictures, so you can just look at me while I talk. So this is the title slide. The title of this talk is Snakes on the Web, and it's about the use of Python on the web, both the history of Python on the web, and I'm going to try to make some predictions about the future. You may recognize the title. I, in fact, gave this talk about 2 years ago, in 2010 at first. So this is an updated version. If you're interested, you might want to check out the original version. I have it right up on my website, and see, you might be interested to see what's changed. My thinking in this area has changed somewhat. Some things have stayed the same, other things have changed. I have a lot more clarity now than I did a couple years ago, I think, about what the future of the web is going to look like, and I think I have a better idea of what Python needs to do to continue to be a dominant language on the web. So let's get into it. So the truth is that web development is really not that much fun. It's a pain. It's very repetitive. We do the same things over and over and over again. We build the same sites. We solve the same problems. We just do the same things over and over and over again. The sort of dirty secret of web development is that much of the time it's boring and tedious and uninteresting. And the history of web development can actually be really summed up by asking the question, what can we do to make web development suck less? How can we make web development easier? The entire history of the tooling around web development can really be thought of as a struggle to make our lives easier, to make this job more interesting, more exciting. Let us focus on the things that are fun and that are interesting and that are exciting, on the things that make our sites different, and let us spend less time on the parts of our job that we have to do over and over and over again. So if we want to think about the future of the web, we can do it by sort of asking ourselves a few questions. We can ask, what's broken about web development today? What's hard about our jobs right now? Web frameworks make our lives easier in many ways, but they make our lives harder in a few. So what are those things? What is broken? And I want to talk about what we can do to fix these things, what these problems are, how we might be able to fix them. And by looking at how these things might be fixed, we can start to think about what the future of the web might look like. And of course, since this is PyCon, I want to follow it up with a very important question, I think, to all of us, which is, can we fix these problems with Python? I don't know about you, but I want to keep using Python for web development well into the future. I don't want to have to switch. I think Python is the best language out there, and I want to keep using it. So how, then, can we solve these problems in web development using the tool that we're here to talk about? So what I'm going to do now is talk a little bit about the history of the web, colored through my eyes, colored through the standpoint of the author of a web framework. This is how I see the history of the web. So way back when the web was young, we had very, very primitive tools. In fact, the first few websites that I ever built were all just hand-rolled HTML. We just wrote HTML by hand. No interactivity, no scripting, no really back-end per se, just documents up on the web. This is obviously like a huge pain in the butt, right? And more importantly, it's completely limited, right? We can't actually do anything interactive. We can't publish database content. We can't have chat. We can't have tools like Gmail. We can't build stuff like that if we're doing everything by hand. But even for simple things, if you're publishing a newspaper, do you really want to have to mark up every single story by hand in order to put it on the web? I mean, of course not. That's terrible. So within a few years of the web starting to become useful, we realized we needed a better set of tools, a better way to create websites. And the first generation of these tools was CGI. Anyone remember CGI? A lot of fun, right? Python still has CGI support. There's a CGI module. You can still build CGIs in Python. Mostly, in the early days of the web, CGIs were written in C, actually, and then Perl, eventually. This also isn't a ton of fun. It's very slow. The process model involves sort of booting the interpreter new for every request, so it doesn't scale to modern traffic, well at all. And in order to have sort of a moderately sized website, you start needing to have, tens or dozens or hundreds of little .cgi files kind of all scattered around. Or you do sort of like the dispatch approach, where you have like a, site.cgi, and you pass everything through one master monolithic disgusting script. And it just gets really hairy, really hard to maintain, really difficult, and doesn't provide us with any sort of reasonable level of abstraction. I don't think that there's a mistake that we didn't see very ambitious websites springing up during the CGI age. It's because the tooling is so primitive, it's hard to imagine building anything complex. So out of CGI comes a sort of offshoot, which is sort of the PHP model. PHP is better than CGI in some ways, but it's not really an ambitious move. It's basically, PHP comes about by asking, how do we make CGI better? But it's still conceptually the same idea. You still have individual files on disk. You still have to have many files kind of mapping to what you're doing, or one kind of master dispatch file. PHP is really just sort of a better way of writing a CGI script. And fundamentally, all of these approaches, PHP, CGI, hand-rolled HTML, they all suffer from a fundamental limitation, which is that they are page-oriented. And what I mean is, they encourage you to think of your website as a collection of pages. There's a direct mapping between a URL, blog.php, and a physical file sitting on the disk somewhere. If there's a blog.php in your URL, there's a blog.php sitting on your disk. If there's a blog.cgi, there's a blog.cgi on the disk. If there's a blog.html, there's a blog.html on your disk. And fundamentally, these orient your thinking towards pages. It makes us think of the web as a publishing platform, as something that we take documents and we put them on the web, right? And we're all modern web users, so we know that the web has gone farther since then. But it was hard to think about back in those days, back in the early CGI PHP days. It was hard to think about the concept of a web app. I choose RDO because it happens to be written in Django. And it's a perfect demonstration of the type of application that I don't think we could have conceived of in the page-oriented manner. RDO is essentially iTunes, but in a web page. And if you try to think about that from the perspective of somebody writing HTML files by hand, that's kind of nuts. The idea that we might take a desktop application and write it in HTML, that's crazy talk. But that's precisely the type of thing that these sort of limited, page-oriented tools prevent us from picturing. So what happens, of course, is a few people start thinking about applications, and suddenly we have this massive revolution. We get frameworks. And within a few years, 2004, 2005, there were frameworks before then, and there still are frameworks, but there was this point, this moment, just a couple of years when frameworks just exploded out of the woodwork. Django, Rails, Symfony, TurboGears, Pylons, Pyramid. What else do we have? Zend. Cake, JSON, Plex, I don't even know what some of these are. Frameworks just blew up. We went from not really talking about this word framework to it being an almost obligatory part of the web. And so what happened? Why did this happen? Why was this a big deal? Why did the entire web community lock on to web frameworks? Well, I think it's because of a couple of traits that modern web frameworks share. And I'm using the term modern here to differentiate this generation of web frameworks from the previous generation that for various reasons didn't seem to catch on. And I think these traits are important because they tell us a lot about what we want to do as web developers. So modern web frameworks are high level. They encourage us to think of our application from a very sort of high level standpoint. You know, we're familiar with this concept because we know Python is a high level language. If you're writing in C, you have to think about things like memory allocation and pointer arithmetic. You're very close to the metal, you're very low level. But when we step up to a language like Python, we're not thinking in terms of pointers, we're just thinking in terms of data structures and algorithms. We don't have to think about the details of HTTP over the wire when we use a web framework. We just think about serving requests and responses. We don't have to know what's going on at a very low level. So web frameworks want us to think at a very abstract, high level about our jobs. Web frameworks typically are application-oriented. This is, I think, the most important thing that web frameworks give us, is they encourage us to think about what we're building as applications, not as pages. We're not using the web as a publishing platform. We're using the web as a platform, as a generic, bona fide platform in its own right. The web now, we can draw almost a comparison between, you know, Linux, Mac, Windows, the web. The web is almost an operating system in a way on par with desktop operating systems in terms of the way that we can think about the web as a platform to build applications. This is huge. This is a massive change, and frameworks encourage us to think about what we're building as applications. Frameworks encourage us to work on the order of large blocks. We're not as much writing code from scratch when we use a web framework as we are composing units. Some of these units that we write ourselves, others that are open source, others that we reuse across all of our projects. Almost every web framework has some concept of plugins or add-ons or, in Django's case, reusable apps. We are taking components, larger components, a blog, social registration, authorization, template rendering, kind of plugging these components together rather than operating on a very low level, bit-by-bit basis. And frameworks encourage very rapid development. They're trying to get us into a mode where we develop and iterate rapidly. This is one of the reasons I think why web applications are tending these days to win out over desktop applications. We can iterate and ship much more rapidly. If we find a bug, we can fix it and deploy that to all of our users instantaneously. We don't have to wait for everyone to upgrade. They just get the new version the next time they reload the page. I don't think it's a coincidence that all of the popular web frameworks are open source. However, this is an open source conference, so I'm not really going to spend much time justifying why I think that is. I think that everyone here understands the value of open source, and I'm not really going to preach to the choir, as it were. And finally, modern web frameworks are fun. And this is something that I think business people sometimes underestimate. I've spent the last few years kind of getting sucked into the world of enterprise software, and there's a lot of disdain in the enterprise world for fun and for experimentation and for excitement. You know, the enterprises needs to be suit and tie, button down, serious software. But the fact is that, as I said at the outset, web development is kind of boring, kind of uninteresting, kind of repetitive. And if we have tools that make this job fun again, they remind us what it is we love about the web, what it is we love about software development, and they encourage us to develop, to do our best, to think broadly, to think in a grand manner. One of the best things about web frameworks is by taking away the boring parts and giving us tools that are exciting and fun to use, they encourage us to think beyond the constraints of what we have before. They encourage us to think about doing crazy things like building a music player in a web browser. It's very important that we have tools that encourage us rather than hold us back. So that's where we are now. So what's next? To think about what comes next, I'm going to come back to this question I asked at the beginning and say, okay, what problems, what sucks now, what's broken as it is right now? And I see a couple of areas that are especially hard. I see a couple of areas where web frameworks really are just falling way behind and in fact getting in our way. So interoperability is the first one. The first thing we have to do when we're starting a new project is pick a framework. Doesn't that seem kind of weird? Am I the only one that thinks that's kind of strange, that before we've written any code, we have to pick what to base it on? I mean, we don't really know, right? When you're starting a new project, do you know what your needs are exactly? Do you know what it is you're building completely? No, I mean, most of the time, you have a vague idea what you're building. You maybe have some specs. Maybe you just have a rough idea of a product you'd like to launch. Isn't it weird that we have to lock ourselves into a limited, constrained set of tools first? You know, you don't realize you've chosen wrong for weeks, months, even years. That's kind of a problem. You know, frameworks are good because they help us get our job done. But unfortunately, frameworks already lock us in, right? We're stuck. If you've built an app on Django and you decide it's wrong for you, that Django's not the tool you want to use, how much engineering effort is it to switch away? It's a lot, right? If you decide, and that's only if you're switching to another Python web framework. You know, what if you decide that Python's the wrong tool? Now switching away is just ridiculous. So we get locked in very, very quickly. And as people writing tools, as people producing software for other users, as people writing frameworks, this is that. We should not be gaining popularity through lock-in. That's not the open source way. We're not Microsoft. So we need to remember that, you know, the primary rule of open source is to don't piss off your users, right? We're not dealing with a situation where there's a large financial cost of switching to a different tool. You don't have to buy a new web framework. You just have to leave. So the fundamental unit of currency we have in our community is goodwill. And we need to do the best we can to keep our users happy. And what that means when it comes to web frameworks is making it possible to move away quickly. What happens is, over time, your website becomes domain-specific. And what I mean by this is, you'll start out writing a website, and perhaps Django's template language is what you choose, and it works well for you. For most websites, you know, like most parts of Django, the template language is sort of designed for some sort of average area. It's okay for most people. It's not really the best for everyone, but it's mostly okay for almost everyone. But over time, you might discover that the tool you're building just doesn't work with those constraints. Maybe you end up building maybe you're building a blogging platform, and you want to give your users the ability to skin the website. Well, Django's template language isn't sandboxed, so you can't let untrusted users edit their own templates. That would be a security problem. So now you're in a situation where you've chosen a framework because you've chosen a template language because the framework handed it to you, and now you have to switch away. what's happened is your software has gone from being general, rendering templates is something every site needs to do, to being specific. Now you have a domain-specific need, and your software needs to grow to match that domain. How easy is it to throw away Django's template language and replace it with one, Jinja that does have sandboxing? The best frameworks cede control gracefully. I've chosen templates perhaps because it paints Django in a pretty good light. It's easy to switch to a different template language in Django. It would be much harder to switch to a different ORM if Django's ORM didn't do what you wanted it to do. It would be even harder to switch to a different authorization system if Django's auth system didn't do what you wanted it to do. It would be nearly impossible to switch to a different routing system if Django's routing system can't do what you want it to do. So, different frameworks have different sort of amounts of lock-in at different levels of their stack. And we should try to remember that our goal should be, as software grows and as people's sites become more domain-specific, as they need to more and more replace components that don't scale with what they're doing, we need to remember to the best framework should sort of gradually recede into the background. Gradually, you should be able to replace it bit by bit until one day you realize that you're really not using it anymore. You've now replaced every generic piece with a specific piece. This is how software ought to evolve. There's also interop problems between frameworks, of course. You can sort of use multiple frameworks together. You can kind of knit together different Python web frameworks at the WSGI level. But it feels very clunky, right? Anyone who's done this knows that it's a very coarse-grained, very rough, very, un-Pythonic way of knitting together multiple applications. I think we can find some areas in common. I'm not sure that we can necessarily end up in a situation, even that we want to end up in a situation where there's kind of one master Python web framework to rule them all. In theory, Django could throw away its internals and replace them with Pyramid. But I'm not entirely sure that's realistic. We're open source here. We don't get to operate on the basis of 5-year plans, right? We don't get to plan out these massive engineering efforts and execute them. We work in a much more haphazard, incremental, bit-by-bit way. But I do think, even if we can't have sort of true framework interoperability, we do have common problems. Chris McDonough, the author of Pyramid, gave a talk at DjangoCon where he talked about this, and he pointed out that all of us, everyone in the Python world, is dependent on Python packaging. And Python packaging is not particularly fantastic right now. One of the things he mentioned was that virtualenv is a tool that most Python programmers ought to be using, but it's actually really hard to explain to new programmers why they should bother. It's a weird little tool. You don't really know that you need it kind of until it's too late. And none of our different communities is doing a good job selling that tool to our users. And so, sure, we take documentation really seriously, and we could add some virtualenv stuff to Django's documentation. But why should we do that in a Django-specific way? Why not contribute to the virtualenv documentation and help the entire Python community? There are these areas that we all depend on, and we could all work together on improving them. WSGI still has problems dealing with streaming responses. Well, we could, all get together and do that rather than having a Django-specific solution and a Pyramid-specific solution and a Flask-specific solution. So we should be working first as Python programmers, and maybe second or third as Django programmers or Flask programmers or Pyramid programmers. And we should be identifying these areas where we can work together and working to improve these common sets of things. I think in the Python world, the way that we're going to solve interoperability isn't through some grand sweeping plan and some grand sweeping vision, but the way that Python programmers kind of solve everything, a little bit at a time, bit by bit, like a snowball rolling downhill, gradually getting bigger and bigger. So I talked about RDO, and recently we've seen more and more of these just really amazing, fantastic, rich applications. Can any of you remember the first time you saw Google Maps? Because it blew my frickin' mind. I just couldn't believe that anything like this could be built in a web browser. It was totally mind-boggling. I had the same experience the first time I saw Google Spreadsheets, and a dozen people editing a spreadsheet all at once. Again, it was kind of like, whoa, what's going on here? People are doing things on the web now that I don't think we knew were possible until a few years ago. You know, normally this all gets lumped under the banner of HTML5, and I'll use that term here. I know it's not quite the right term. It doesn't encompass CSS and JavaScript and et cetera, but allow me to take a liberty, and I'm going to use HTML5 as a shorthand for all the cool stuff going on the front end right now, all the cool things that are possible in web browsers that weren't possible just a couple of years ago. And I think HTML5 might be the best thing ever to happen to web frameworks, because suddenly Django is a competitor to Cocoa, right? Suddenly back-end web frameworks are competitors to front-end application development tools. Now if I'm trying to choose, I want to write a new mobile app, right? Well, I have an even choice. Do I write this app using the Android-specific APIs, or do I do it as a mobile website? The fact is, both are kind of equally compelling. We actually have a couple of good choices, and they're not just about do I want to make this for Mac or Linux, right? So this new browser stuff might be the best thing to happen to us framework people, because it suddenly pushes the boundaries of what we're able to do as web developers. We're no longer just on the web. We can now push stuff onto phones and onto desktops in a way that we previously couldn't. However, our current crop of web frameworks just don't fit. They simply don't get us to where we want to go. When I said, Django as a competitor to Cocoa, anyone who's programmed in both probably gave me a look and said, no, what are you talking about? Because the fact is, it's a lot harder to write RDO as a web app than it is to write it as a desktop app. Still. And the biggest place where all this starts to fall apart, where just the whole thing blows up in our faces, is the so-called real-time web. And what we mean by real-time web, essentially, is where changes that I make in my web browser are automatically synced back to the server and then propagated out to everyone else's web browser. When I talked about, simultaneous editing, that's real-time. That's the type of behavior that I'm talking about there. And when you see applications that use it, it's absolutely stunning. So I want to talk a little bit about Meteor here, and I just want to show a little bit of this framework. Meteor is a new web framework. It's maybe 6 months old. And they have this screencast. If you go to their site, it's just meteor.com. They have this screencast there. I'm going to show you some clips from it. And it's the most exciting thing I've seen in web technology since I watched the Rails screencast, whatever, 8 years ago, 9 years ago. It's the most compelling new thing to happen to web development. So I want to show you a couple of clips here. I'm going to try holding my little microphones up so you can hear the narration. We'll see if this works, but I'll tell you, even if you can't quite hear, I'll explain to you why I think this is interesting.
This app is just a list of my favorite colors. It says no colors yet, so let's add some. I go into the console. Since we're using Mongo, I'm just going to type some Mongo command. Insert red. And as I type the command, the screen updates. Let's see that again. Insert blue, insert green. Two things to note here. First, the DOM is updating immediately, all by itself. I change the data, and the template updates. There's no callbacks, no bindings, and no controllers.
It just works. Second, somehow, I'm using a Mongo API on the client. You've never seen this before. Up until this point in history, database APIs only worked on the server. But in Meteor, there isn't a server API and a client API. There's just a Meteor platform API, and it works everywhere.
Let's be clear. All of this is being saved to the server. Take a look. I open another browser, and it's all here. You don't have to define a bunch of endpoints on the server and make the client call them. Meteor wires it all up for you.
And when we say that Meteor wires it all up for you, that goes in both directions. Not only are these changes being saved back to the server, the client is also listening for changes coming back down from the server. So when I make a change in one window, it automatically appears in all other windows without any other code. Think about it.
So think about it, right? Just like you said, what's going on here is I've got some JavaScript running on the front end. I'm actually typing, I'm interacting with MongoDB in my JavaScript window, in my browser. That data is being pushed back to the server, persisted in MongoDB, and then somehow magically coming back to my browser and simultaneously being rendered in multiple browsers at the same time. And this is 4 lines of code. Right? This blew my mind. If it doesn't blow your mind, you're not paying attention. This is when they say in the screencast this isn't something you've seen before, this isn't something you've seen before. You may have seen pieces of this, you may have seen code that does this, but not this easy and not this slick. So let's show a little bit more, and then I'm going to talk some more about it.
Now, the whole point of most software is to let people collaborate and exchange information. So let's add a feature like that. How about a like button so people can say what colors they like? It's 5 lines of code, a button, an event handler, and 1 database command. Pretty slick, and of course it's fully synchronized.
I don't know if you noticed when the votes changed, the items actually resorted themselves. So the front end actually understands sorting behavior that's also somehow known on the back end, as there's an event coming from this window saying, increment green, and then green knows to resort itself in that list. So it's really easy to snark about Meteor, right? I mean, you've got MongoDB commands in the front end. There's no authentication. Yikes, that's really scary. They're solving authentication right now. It's taken them a long time. Clearly, trying to solve this problem is rather difficult when you're exposing your database all the way up to the web browser. They took a ton of venture capital money. This is totally weird. I was very disdainful of it. I still am. I think it's a mistake. But set all that aside, I don't know that Meteor necessarily is like the one true web framework that's going to, blast off and become hugely popular. There are some reasons that it might. There are some reasons that it might not. But we're deluding ourselves if we think that this is not the future of web applications. Perhaps it'll be a different tool. Perhaps it will look, the actual software will look very different. But this is how web applications will look in the future. This is a glimpse through a time portal a couple of years into the future. If we think about real time from a user perspective, we actually might discover that it's a more natural way of thinking about thinking about applications. I mean, the traditional website is kind of a weird thing where we think about filling out a form. We sort of type a bunch of stuff into a form, and then we click submit, and the browser kind of bundles up that form, sends it off to the server processes it and thinks about it, and then kind of kicks back an answer back at us. That's weird, right? Like, what desktop applications work like that? You don't tell iTunes, I want to play this song, and then that song, and then that song, and then that song, okay? And then iTunes kind of thinks about it and says, oh, wait, no, you can't play that song. You just press play, and music plays, right? And if there are multiple people all viewing a document, why shouldn't I see where my friends are in that document right now. I actually think real-time is a more natural user interface. I think it makes more sense to users than this sort of transactional way that we've traditionally thought about websites. I think most websites would benefit immensely from having some sort of baked-in support for real-time applications in a sort of easy, transparent, simple way. I think the only reason that we're not building this stuff into our websites right now is because it's freaking hard. So is this possible in Python? I mean, we've seen a few talks actually here at PyCon India on Python and the real-time web. So clearly it's possible. There's one demo I want to point you at. Preston Holmes is one of the other Django contributors, and he built a sort of proof of concept of what a real-time application in Django might look like. And you can go check out the code. It's pretty well written, it's pretty well documented. You can run it locally. It's basically an application that lets multiple users choose their favorite color, and you'll see everyone else's favorite colors all running in kind of simultaneously. And as I change my color, that gets propagated out to everyone, and I can drag and drop and store. And it's, it's a nifty application, and it demonstrates the same sort of stuff that Meteor is doing in Python using Django and some other stuff. We'll talk about that. So it's possible, but this is what a traditional Django app looks like. You've got your web browser, you've got your Django. You install Django, you write some code, you run manage.py run server, and now you've written an app. So if we think back to application development of, in the CGI era, we're doing like a ton of stuff here that traditionally wasn't all done by the framework. We're building in a web server, right? That's a big one. We don't have to set up Apache, we just run our code. We've got this cool automatic reloading, so as our changes are made, they're refreshed in the browser. Django is including database findings and template engines and form processing and authentication and all sorts of different things that we're getting for free. And so it's letting us think of our application as kind of one logical unit. We don't talk about a bunch of different components when we're using a framework. We just talk about, hey, we're using the framework. It's very, very simple conceptually. We've taken a bunch of hard problems, all framework authors have, taken a bunch of hard problems, encapsulated them into a set of best practices, and handed it to users on a silver platter, saying, now you can build a website. Django and similar tools make it very, very easy for people who don't know a ton about the web to nevertheless produce compelling experiences. So now let's look at what we have to do if we want to create a real-time app. Well, we've got Django, but we also need EVENTLET IO, which I'll talk about. So we end up needing GEVENT. And we need to be able to queue up change events to our models. So those get pushed into a Redis queue. And we need to be able to communicate with the browser, so we need socket IO to communicate with the browser. And on the browser side, we need a library to, on its side, be able to talk to socket IO and deal with the models. So for that, this demo uses Backbone. And so we have this whole complicated set of pieces that all fit together. I can do this. Probably many of you can. You're here at a conference on Python. But this is not accessible to new users. Either users new to Python, new to Django, or new to web development. If instead of just run Django, we told people, well, first you have to install Redis. Oh, did I mention the way you install Redis is by compiling it? That's fun. Now you have to set up GEVENT. There's this little broker you have to create that dispatches either between socket IO and Django. You have to understand how socket IO communicates with the browser, either over WebSockets or a long polling fallback. You have to understand how to use Backbone on the client side, which probably means that you have to understand assets and also some CSS and HTML and DOM manipulation. Is anyone overwhelmed? I'm trying to overwhelm you. That's the point here. If that sounded like a bunch of gobbledygook, that's because it is, right? So let's look at what you need to do to actually pull off real-time in Django. Takes about 750 lines of code. Again, I'm using Preston's example here, which is actually not bad. When I went to count the code, I expected it to be a lot longer. That's not bad. That's actually reasonably understandable. You can read through it all in an hour and understand how it all fits together. That's really pretty good. I was surprised. However, there's actually 18 external packages. right? Django is one, but then there's like all of these other ones. I actually don't think I'm counting Django in there, so maybe 19. Anyway, so that includes stuff like Redis and Socket.io and GEVENT and Unicorn and et cetera, et cetera. You end up actually with 4 different services that you have to run and start. So instead of manage.py run server, it's like start Socket.io, start Django, start Redis, there's, what's the other one? Anyway, you end up with like 4 different running processes that you have to actually orchestrate, which means, you know, that's also kind of a nightmare from an operations perspective. So let's compare that to Meteor, to the equivalent application. It's not exactly the same, it's not the color app, this is the voting thing that I showed you in the screencast. So that's 12 lines of code. It fits on a single screen. There's no external libraries other than Meteor itself. It's just Meteor. And there's one running service, Meteor. Right? So which one of these is more accessible? Which one of these is easier to wrap your mind around? Which one of these is easier to use? Now, behind the scenes, Meteor is doing almost exactly the same thing. There's Backbone on the client side. It's communicating over Socket.io, something very similar to Socket.io. There's a queue that is pushing change events to and from the server and between the various clients. It's doing most of the same things, but they've just bundled it up into one package and made it very, very simple and very easy to use. So really, the question isn't, is real-time possible in Python? Because we know that it is. People are doing it right now. There are clearly real-time sites written in Python that are already out there. So the question is really, is it easy? Are we doing this in a way that's accessible? Is it as easy to write a real-time site with Django as it is to write a traditional transactional one? And the answer, unfortunately, is no. I am convinced that when you watch the Meteor screencast, and I do hope you'll go watch the whole thing, it's really cool, and it just demonstrates, it opens your mind to what's possible on the web. I am convinced that this is what the future of the web looks like. I'm not convinced that it will be Meteor, as I've said, but I'm convinced that from a user standpoint, real-time is where we're going. And as Python developers, Django is by no means alone here, as Python developers we have 2 choices. We can adapt to this new world, or we can let ourselves be swallowed by other languages and other frameworks. Of course, this becomes hard because concurrency in Python is a minefield. With the traditional transactional website, concurrency isn't much of a problem. You just run a bunch of Apache processes or Unicorn processes, you scale those horizontally among a bunch of servers, and you basically you do concurrency outside of Python. It's really kind of not a problem. But once you start introducing real-time web to the equation, concurrency gets a lot more complicated because this requires holding open a persistent connection from your server to every single currently connected web browser. Somebody asked me yesterday how load balancers deal with WebSockets, and I started laughing because the answer is not well at all. We can't really say when it comes to real time, oh, this is Apache's problem. Unfortunately, if we're going to build real time into Python, I think it's probably Python's problem or our framework's problem. The fact is that we're heading into a world of multi-core. CPU improvement in terms of raw speed per CPU has basically topped out. We haven't seen a lot of, what's the fastest CPU you can get today? Like still sort of south of 4 gigahertz, right? And we were able to buy, 3.5 gigahertz CPUs like 5 years ago. Like we haven't really been pushing the boundaries. And there are people smarter than you who understand why this is. I think it has to do with die size or something. So what's happening instead is rather than making CPUs faster, we're making them more concurrent. This is, I guess it's Oracle now, but I still want to give the credit to Sun. This is Sun's latest architecture, the Spark T4. There are eight cores on each die. Each one of these is a CPU core. So there's 8 cores on a single chip. And each of those chips exposes 8 hardware threads. So this is 64 CPUs, in effect, in a single tiny little die, right? This is 64 CPUs on a chip. And in one rack mount unit, you can cram 4 of those CPUs. How they cooled this thing, I have no idea, but you can cram 4 of those into a single box, which means in one U, you can get 256 hardware threads on a single machine. Unfortunately, most of our software can only take advantage of one thread at once. This is a screenshot of a 16-core Mac running Photoshop. Good thing you bought those 16 cores, right? And so most languages, including Python, really only take advantage of a single core at once, right? You've heard about the global interpreter lock. That's part of it. But there's more to it than that. It's that our current threading primitives have trouble dealing with the multi-core world in a way. It's complicated. It's a very hard paradigm. You know, threads by themselves aren't necessarily bad, but they're hard for programmers to wrap their minds around. I understand threads pretty well, and I still write software that looks like this. You know, we have a lot of options in Python. There's Twisted, it's been around forever, Tornado, GEVENT, EVENTLET. There's probably 3 others that I left off the slide. I added this ... like 10 minutes ago because I realized if I didn't have it on there, someone would say, well, what about? Because there's a ton of really good options. Unfortunately, none of these really kind of like fit together very well. They're not. We don't have a coherent answer to multiprocess. And again, to come back to the interoperability standpoint, if you choose Tornado for your concurrency and I've chosen GEVENT, we probably can't run our software in the same process. We probably can't use our tools together. So that kind of sucks. And you know, similarly, there are a ton of there's a lot of work in this space, right? There's been a huge amount of academic research into concurrency. There's a lot of much smarter people than me who work on this stuff. If you want to know more about sort of the concurrency and the sort of models for it, a great place to get started is this article by Ted Long, A Survey of Concurrency Constructs. Most of what I know about this space actually comes from reading stuff Ted has written. And I don't have a point to make here, unfortunately, because I'm not smart enough. I don't actually understand this stuff that well. So really my point here is just help, right? We need a better answer here. It's not going to come from me. Maybe it'll come from one of you. Okay, so by way of conclusion, I want you to try to imagine what web development looks like in 2020. This is not entirely an arbitrary date. 2020 is final call for HTML5, so it's supposedly the date by which HTML5 will be done. I don't think, I doubt it. But in theory, 2020 is when WebSockets is supported by all web browsers. Remember, final call means, in order to pass final call, it means 2 alternate implementations. So it basically means, you know, like WebKit and Gecko and whatever Microsoft wants to do is fine. So this is roughly when we'll be able to actually count on this stuff being like mature and stable and well documented and ready to go. Possibly before if people move faster, but it's a good date to think about as like when the next generation of web development is really fully here, right? When we think of web development circa 2012 as sort of backwoods, you know, hicks scraping stuff together with stones. So I don't know about you, but I want to be using Python in 2020. I see no reason why I shouldn't be using Python in 2020. I really hope I don't have to be using JavaScript. I'm not sure that Django is going to be the tool that can take us a decade into the future. It may be that our current crop of web frameworks simply can't adapt. I may, in fact, be talking about the next generation of web frameworks. maybe this will inspire one of you to make it. Of course, I want it to be Django, and I'm going to do what I can to make sure that it is, but it's fine with me if it's something else, as long as it's Python. The thing is, as Joel says, good software takes 10 years. So we're 2 years behind, folks. We got to get moving. Thank you. I can take questions for maybe a couple of minutes. Is that okay? And there's a microphone here, so if you could ask your question in the mic so people can hear. Anyone? And if you could speak slowly, there's a lot of echo up here, so I'm actually having trouble hearing myself even.
Specifically in the context of what you talked in the end, concurrency and making interoperable concurrent frameworks, what's your view on the necessity of immutable data structures in Python itself?
On immutable data structures or immutable objects in general?
You could take it either way, but if you want backward compatibility with what we've got in Python, I would imagine it would just be immutable data structures.
Okay.
But feel free to react either way.
Right. I mean, so some languages solve concurrency. I'm sure this is where your question is coming from. Solve this problem by basically making everything immutable. Or I'm thinking of Erlang here. And there's no way Python's going down that path. It would just be too monumental a change. I don't think even Python 4 would do that. Is anyone talking about Python 4 yet? I hope not. Yeah, I mean, immutability is one answer. I'm really intrigued by the work that Armin Rigo is doing on STM, on software transactional memory in PyPy. Because I think to me that seems to be, David said this yesterday, I think this seems to be the most Pythonic solution. Because it's not immutable data structures, it's like optimistically immutable data structures. You get to make a change and then you only have to sort of make a copy if something goes wrong. So, as a noob, I think that STM seems like the best from a user standpoint. But, it may be that we need some sort of immutable primitives as part of the language. Again, I don't really know. I think that historically Python has been really good at stealing great ideas from other languages. So hopefully there's someone out there doing research on what other languages do and saying, oh, Haskell does this, and Erlang does that, and JavaScript does this, and here's how we can kind of pull it all together into like a Pythonic solution. So that's definitely one of the things I would want to look at.
Hi, my name is Haridas. I heard about there is a slight, some difficulties while implementing sockets. The real-time web thing using WSGI, that Django's request response cycle. The current thing is doesn't support that much. So can you please give us a little idea about what are the difficulties in that while the socket implementation, the real-time on this WSGI module?
Right. I mean, the current WSGI standard is just not suitable for WebSockets. WebSockets does this weird thing where it starts out as HTTP and then switches to the WebSocket protocol. So I think if WSGI is just going to freak out. That's why if you go look at the Django Live example, it's actually detecting a socket IO connection and switching over to a different service that's not really WSGI. So you effectively need this little proxy to swap between traditional HTTP and then WebSockets.
You require another solution rather than WSGI.
Yeah, I mean, so maybe the solution is in improving WSGI. I think that's probably where that needs to go. Python's low-level sockets are going to support WebSockets just fine. It's just a network connection. But WSGI certainly doesn't, so there probably needs to be work on the spec level as well.
Thank you.
Yeah. Up in front here.
considering the real-time applications that we are talking about in the entire presentation, are we looking at some core changes being made in the Django core itself so that we can actually bring in the real-time aspect, or do we have to rely on third-party apps or tools to integrate it along the way? We showed the Meteor part there, but gradually speaking, since the database gets exposed to the client end, it's not at all suitable for building some enterprise or, let's say, production-related apps. So are we looking at some changes being made in the core Django modules, or how are we looking at ahead? How's the road plan ahead?
Right, so I should be clear that I don't get to decide what happens with Django, right? I'm one of 30-ish committers and one of thousands of community members, and no one rules unilaterally. I have some ideas, but I'm hoping that the community, will follow what the community wants. So that said, this demo came out of DjangoCon, which we held about a month ago, and one of the Meteor creators actually gave a keynote at DjangoCon, and there was a ton of discussion about real-time web. And there seems to be a growing consensus, a pretty strong agreement among most Django users that, yeah, there should be changes to the framework itself, that Django can sort of push things along in this direction. Adrian made the point that, Adrian Halvadi, the creator of Django, made the point that not every website is a chat site, right? Not every website needs like really awesome, baked-in, amazing real-time concurrency. But a lot of websites can benefit kind of from a little bit of it. And we can probably do a really good job delivering on that, again, that like sweet spot, that 80% that most people use. I don't see any technical reason why we can't put that in the framework itself. And I think I see a huge number of benefits. We can come back to manage.py run server again, and just everything kind of magically works for you. I think we can. I think Django in 2 years could compete favorably with Meteor on the lines of code and a number of dependencies, metrics, and I'd like to see us try.
Hello. So with the rise of real time, I think that apps are more suited than browsers. So what are your views on how Django can work better with app-oriented real-time world, and your views in general about browser as a consumer of the web versus apps as a consumer of web?
So are you talking about sort of the distinction between like a web application built using HTML and associated web technologies like a mobile app or something? Yeah. I mean, so I actually consider iPhone apps to be web apps. They're built, the front end is in HTML and JavaScript, but they're talking over the web to back-end web services. And as far as I'm concerned, like, from my standpoint as a Django developer, as long as it's like, as a Python developer, as long as it's Python on the server, I kind of don't really care so much about what's on the client. Like, I think that we're not going to get Python into a web browser. That's just not realistic. So we can't expect, the front-end language necessarily to be Python. But I think we can stake our claim to the back end. We can say we're going to be the absolute best on the back end here. And obviously the real-time web introduces some challenges in that we have to start abstracting some stuff on the front end. It's not useful to people if we say, hey, Django does all this stuff, now you have to learn Backbone. We need to abstract some stuff and make it easier for them. But I do think that we can actually kind of live in a world where it doesn't really matter what people are doing on the front end, and we're just sort of providing really awesome back-end tools for them. Does that make sense?
What my question is, as the front-end language changes from say HTML to so many different diverse technologies, how does Django say remove the templates, or how do you see 2020 that everything is an API, or how does that work?
Yeah. I mean, part of this whole equation is definitely more sort of data agnostic APIs, right? I mean, the traditional Django app kind of renders directly the HTML, but if your front end is an iPhone, you're probably not doing that. So, certainly part of this equation is getting some better API support kind of into Django or you know into the community in a sort of more pervasive way. Yeah. I think maybe we'll do one more question and then you can please do find me. I'll be here all day today, and my email address is up there. I'm on Twitter. I'm on GitHub. All that fun stuff. Yeah. So go ahead.
Hi, I'm Prem here. I want to thank you for a nice presentation. I'm not a web developer, but I have some interest in that. So I hope my question makes sense.
I'm having trouble hearing.
I hope my question makes sense because I'm not a web developer, but we have like different web HTML5 and so on and that. But everything is an abstraction of the CGI at the low level. The frameworks still use CGI.
They don't actually. Frameworks haven't used CGI in a long time.
Okay. So how do they communicate with the web server and the web browser? Which technology?
So that's what WSGI is. WSGI is Python's web server gateway interface. It's how a web application communicates with a web server. Thanks, everyone.